Hello, students. Today we're going over the 3.4 notes in Algebra 2, solve systems of linear equations in 3 variables. This is something new that you haven't seen before, unlike many of the sections in Algebra 2 thus far. The great news is this is also the last set of notes for this chapter. So let's go over some vocabulary first. First, we'll go over linear equation in 3 variables. This is an equation with variables x, y, and z. So we're not just working with x and y. Okay. The solution is going to be an ordered triple, x, comma, y, comma, z. So there's 3 parts to your solution this time. It's a 3-part point. The equation for a linear equation 3 variables, I should note, looks something like ax plus by plus cz equals d. Okay, so there's just the x, y, and the z. A, B, C, and D are numbers. Okay, so we use the elimination method when we solve for a 3-variable system. This tends to be the easiest method. I do have the steps written here. However, like I've said in previous notes, I believe the easiest way to figure it out is by doing a problem. So I'll explain the steps as I go in example 1. Notice we have a system with 3 different equations, 3 variables in each equation. I like to label these 1, 2, and 3. This helps me keep track as I go along. My goal is to use 2 of the equations first to eliminate a variable. I think I am going to eliminate variable y. So I am going to rewrite these equations alone to get an idea of how to do that. So I have equation 1 and I have equation 2. To get rid of the y's, they're already opposite signs. If I multiply equation 1 by 4, it should eliminate those y's. So then I get 8x minus 4y plus 24z equals negative 16. Then if I combine these, 6x plus 8x is 14x. The y's cancel out. Negative 5z plus 24z is 19z. And negative 7 plus negative 16 is negative 23. This is what I call new equation 1. So new equation 1. Now, I go back to the original problem. I'm going to use 2 other equations, 2 separate equations. So I used 1 and 2. Now I can either use 2 and 3 or 1 and 3 to eliminate the variable y again. So to eliminate it again a second time, I am going to use equations 2 and 3 this time. So 6x plus 4y minus 5z equals negative 7. Then for equation 3, I have negative 4x minus 2y plus 5z equals 9. If I take equation 3 and multiply the entire thing by 2, then those y's should cancel out. So I have negative 8x minus 4y plus 10z equals 18. I'm going to write equation 2 below that and add them together. When I do that, negative 8 plus 6 is negative 2x. The y's do a cancel out. 10z minus 5z is plus 5z equals 18 minus 7 is 11. This is new equation 2. So now I'm going to take those 2 new equations. New equation 1, new equation 2. I'm writing them down. And now I'm going to eliminate another variable. So looking at these 2 new equations, it would be easiest to get rid of the x because I can multiply this new equation 2 by 7. It gives me negative 14x plus 5 times 7 is 35. Z equals 77. Write that new equation 1 right below it. When I add these together, the x's cancel out. 35z plus 19z would be 54z. And 77 minus 23 is 54. I'm going to divide both sides by 54. So I get z is equal to 1. So I have my first variable. Now, to find another variable, I can use one of those new equations from up above. Replace z and find x. So I'm going to go ahead and use new equation 2. And it doesn't matter. You could use new equation 1. It's totally up to you. But I'm going to use the negative 2x plus 5z equals 11. I'm going to replace z with 1. Negative 2x plus 5 times 1 equals 11. And I'm going to solve now for that x. So I have negative 2x plus 5 equals 11. Subtract the 5 from each side to get negative 2x equals 6. Divide by negative 2, and I get x equal to negative 3. Woohoo! We have another variable. So now we have x and z. We just have to find y. To find y, we'll use one of the original equations, either 1, 2, or 3. Totally up to you. I'm going to use equation 1. 2x minus y plus 6z equals negative 4. This time I'm going to replace x with negative 3. I don't know why, but I can replace z with 1. Now the only variable I have left to solve for is that y here. 2 times negative 3 is negative 6 minus y plus 6 equals 4. The 6's cancel out, so I have negative y equals 4. Divide by negative 1, and my y is equal to negative 4. Now that I have all three variables, I can write my final ordered triple. Remember, we write it as x comma y comma z. So it will be negative 3, negative 4, and 1. And that is our final answer. Notice these are very long, but if you're careful and methodical about the order you do it in, it shouldn't be too difficult to get to the correct answer. Okay, we have another one to solve. X plus y minus z equals 2. That's equation 1. Equation 2 is 3x plus 3y minus 3z equals 8. And equation 3 is 2x minus y plus 4z equals 7. So looking at equation 1 and equation 2, I'm going to go ahead and get rid of the y again. It doesn't really matter. Like I said, you could get rid of another variable. It just looks like that would be easiest. So I'm going to take equation 1. I'm going to multiply the entire equation by a negative 3. So I get negative 3x minus 3y plus 3z equals negative 6. Now I'll put equation 2 below it. 3x plus 3y minus 3z equals 8. And I'll add these together. Negative 3x plus 3x cancels out. Negative 3y plus 3y cancels out. And 3z minus 3z cancels out. This leaves us with 0 equals negative 6 plus 8 is 2. 0 does not equal 2. This is a quick and easy problem because we get this answer that is not correct. 0 does not equal 2. Our answer is no solution. And we are done. Just don't forget to write no solution. Example 3, same process. I'm going to label my equations. Now I'm going to get rid of the y's. I'm going to use equations 1 and 2 first. X plus y plus z equals 6. X minus y plus z equals 6. I can add these together. X plus x is 2x. The y's cancel out. Z plus z is 2z. 6 plus 6 is 12. This is new equation 1. Now I'm going to use equations 2 and 3. X minus y plus z equals 6. Or x plus y plus 4z equals 24. Notice why I picked these. Y eliminates very easily without multiplying for both situations. So here I have 1x plus 4x is 5x. The y's cancel out. 1z plus 4z is 5z. And 6 plus 24 is 30. That's a new equation too. I'm going to go ahead and write these new equations here. Now there's something I want you to notice about both of these. In equation 1, we can divide every single term by 2. That would give us x plus z equals 6. That is perfectly okay. You could divide the second equation entirely by 5 to get x plus z equals 6. Totally okay. Now, looking at these two equations, to eliminate, all we have to do is multiply one of them by a negative 1. So I'm going to rewrite these equations simplified. Multiplying the first equation by negative 1, I get negative x minus c equals negative 6. So when I add these together, notice everything cancels out. We get 0 equals 0. This is a true statement. So we write infinitely many solutions. And we're done. Last problem. We have a word problem here, and it says at a carry-out restaurant, an order of 3 slices of pizza, 4 breadsticks, and 2 juice drinks cost $13.35. A second order of 5 slices of pizza, 2 breadsticks, and 3 juice drinks cost $19.50. If 4 breadsticks and a juice drink cost 30 cents more than a slice of pizza, what is the cost of each item? Write a system, but do not solve. So we're going to write the system that we would use, but we're not going to actually solve it. So I don't know if you noticed here, but they gave us 3 separate equations, one in each sentence. So the first sentence gave us the first equation we're going to write. The second sentence gave us the second equation. The third sentence gave us the third equation. So for that first one, it says that 3 slices of pizza, so let's call that 3p, plus 4 breadsticks, 4b, plus 2j for juice drinks, all those added up, equals $13.35. For the second equation, we have 5 slices of pizza, so 5p, plus 2 breadsticks, 2b, and 3 juice boxes, 3j, which should equal a sum of $19.50. The last one's a little trickier. It says 4 breadsticks and a juice box is 30 cents more than a slice of pizza. So 4 breadsticks and 1 juice drink is 30 cents more than, so 30 cents added to the cost of a piece of pizza. That is our system, and since it says do not solve, we stop here. That's it for today's notes. If you have any questions, be sure to contact your teacher.